Hello friends, this is Mainak and today we'll model some shear wall in STAAD Pro, and also we will do the design in RCDC. We'll see the process of doing the entire thing in the STAAD Pro Connect edition. So we know that in the earlier edition there was an option of designing shear wall, but here it is done through RCDC. So let's go to new and then it will be, let's say, shear wall, and then we'll just give a location for this. So location has been given. Select folder, metric option, and then create. So let's create a model here, just one, and we'll go to view. I've inserted the coordinate and we'll go view and we'll create a model. So we can pan here like this and go to select node cursor. We'll select this node cursor and let's go here by in the X we'll give X 4. Okay, so here we'll go again x4. So we have a grid here, and then in the z direction we'll go again 4. Okay, so we'll have this. Let's connect the nodes here. So we'll go to geometry and then we'll click on add beams option and we'll join the beams. So you can zoom in to improve the visibility. So click on escape and then we'll select this and we can do the translation repeat. So let's go to this view and we'll go to geometry and use the translation repeat option in z direction. So let's say 1.9 meter, including the plinth height and the in the portion below the ground level. So let's go here minus 1.9 meter, default step spacing and link steps, and then click on OK. Sorry, just press Ctrl plus Z, so it would be in the y direction. So go to geometry, y direction, minus 1.9, click on here link steps and then click on OK. So we don't need this, we can delete this because this will be the foundation here. Delete those. Okay, so then we can, so this is done, this geometry of this portion is done. You can press shift plus 1, there is a shortcut. So this is the 3D view and this is the front view. So shift plus 1 is a shortcut for the front view. So press shift plus 1, click here and then press shift plus 1, so you will get this view. Now we can do translation repeat of this one. So go to geometry, go to translation with y direction and then 3 meters, translation repeat here, and then we'll use the link step option and then click on OK. So just a simple structure here just for showing, and then we'll go to properties and we'll go to define here and we'll go to rectangle here. So 0.3, let's give this property for the columns and the beams as well. Okay, and let's give a separate property for the beams. Let's give for the beams 0.3 into 0.4. okay, so we'll assign this for the beams. Select parallel to this 300 will be for the columns, so this will be for the columns, and then this one it's for the beams. Select parallel to x, parallel to z, and then assign and yes, and then again we'll go to so now this portion is completed. So we assigned the beams and slab. So now we need to assign the sorry, beams and column we have assigned, and you need to assign the shear walls, and also you can assign the slabs also if you want. Okay, so for that, for designing slabs, shear walls, so we'll go to use the parametric modeling option if you want to get the results in the STAAD Pro RCDC. Okay, so we'll go to geometry and we'll have the parametric models option here. So you can see the parametric models is ready here. So we'll click on add here. So we'll do this in the anti-clockwise direction from this side. So I'm planning to give the shear walls in this side and this side. Okay, two sides. so it needs to be symmetrical. So we can go, just give a name of it S1 and or SH1 shear, SW1 shear wall 1. So this type will be wall, and slab type is, it's not wall type, so it will be undefined. So method standard, and then just change this. Let's go to here 0.3. okay, give here 0.3 and then click on OK. Okay, so then you have to click on preview models once again, click on add, and in the same way, in the same anti-clockwise direction which we did earlier, we'll do this. Let's go SW2 wall, and this one 0.3. okay, so here we'll just minimize these two mesh, we'll select this and merge mesh, and then we'll select this and merge mesh option will be selected. And similarly we'll do this one. So we'll just rotate the model using the arrows in the keyboard, direction arrows in the keyboard. So we'll go to preview models once again, click left click and then click on add, and then in the same direction, now we're going the clockwise direction for this one. So SW3 0.3. okay, preview models, add, clockwise. And 0.3. okay, so click on this one, merge mesh, click on the top one, merge mesh. So the mesh has been merged here. So if we want, we can also model the slabs here, but we are not doing that right in this video right now. So I'm just showing you the shear wall designs here. So now we'll go to properties once again, properties, and we have here thickness. So this you have the plate element thickness here. So plate element thickness here will define point, let's go with a shear wall of 0.2, that is 200 mm shear wall, and click on add. So we'll just do assign to view, assign, and yes. So these are the shear walls which have been assigned. You can check the control plus 2 this view, control plus 0 will go back to this view, and control plus 4 will give you the rendered view. Okay, press control plus 4 will get the rendered view like this, or else you can also get to the rendered view by clicking on view and then clicking on 3D rendering, also will get the same view. So it is control plus 4. So like this we got this. So the work of properties is completed. Materials, we don't need to give anything here. Specifications also we'll ignore for now. Supports will create fixed supports, which is always needed. Fixed supports will be created, and then shift plus 1 front view, and then select this and then assign. So go to view, and this view will be selected, and as you can see, the supports have been assigned to shear wall, columns, and as well as the isolated columns. So then the loading part will go here. So let's put some basic loads just to give an idea of the loading. Will be a kind of revision. So obviously we need to do the seismic loads. Okay, seismic loads, wind 1, and we'll do IS 875 2015, and click on add and then close. So here we'll click on add, and then we'll click on generate here. This will use custom. The building is in northeast Tripura, so this will be 55 meter per second. Suppose you can check the code and give the basic wind speed, or you can also select the cities here. So these things they take automatically. This you have to select. Okay, we're going with the rectangular clad buildings here, and this importance factors also you can check from the code, and you can modify if required. Okay, so if you do this, if you change this, this will automatically change. So we're going with other structures. Okay, and click on add and then close. Then we'll add a reference load. So we'll add the seismic mass. So this will be mass, and I'll call it the seismic mass just to be very clear, and then go to seismic definition. So this building in seismic zone 5. So in the recent code we have seismic zone 6. This has not been included yet, so we'll maybe study and make a video on it later. Click on generate. So this zone will be zone 5. This is in the northeast India. So special moment resisting frames. We'll go medium soils, and for now we'll not calculate let the software calculate the time periods. Click on generate and click on add, and then we'll close this, and then we'll have the load cases here, and we'll have the seismic horizontal load case, which is SLX add, and then we'll have the SLZ. We'll add this, and we have the dead load DL, and then we'll have the live load LL, and then we'll have, let's give I think wind load in two directions will dominate, this direction and this direction. So we'll have the wind loads, actually let's set wind loads in all the four directions. What wind loads, so W1, and click on add, W2, click on add, W3, W4. okay, so this is done. Seismic load X, let's add this seismic load, seismic in the X direction, click on add, seismic in the Z direction, click on add. So I'm doing the entire step so that if anyone wants to design a shear wall building and clicks here, then they might know the entire process and not have to watch many other videos. So that's why I'm doing the entire steps. Those of you can know, you can just skip ahead. These steps you can skip ahead. Dead load, and then we'll have the we'll have some load for the brick wall here. So the brick wall here, we have 3-meter wall. So for the 3-meter wall, so approximately if you calculate the load of the brick wall, it will be let's deduct some load for the height of the beam, 3 minus 0.4, sorry 2.6, so 2.6 into 19 unit of brick into 0.25. let's take 2.25 thickness wall, so 12.35, so approximately will take 12 load. So flow load, sorry area load, member load minus 12.3, let's take, and then click on GY, then click on OK. And then we've not inserted the slab here, so let's take the slab load also. So here we'll take flow load, and for 100 mm thick slab, 0.1 into 25, so it will be 2.5 plus floor finish of 0.5, let's take 0.3, so 0.5, so this will be 3 kilonewton per meter square. And the Y range, if you go to select, if you go to node cursor, you can see the Y range here 3. So let's give the Y range of minimum 2.9 to 3.1, and then click on add, close. So self weight can be assigned, this can be selected. Click on escape to go back to the normal cursor. This can be selected. We'll just select this like this, press shift +1, select this one and this one. You see this is selected. Okay, done. Yeah, this one we already have the load of the beam, so this is a mistake here. So we'll just delete this, that will be easier. Add member load minus 12.3. sorry, I'm a bit rusty, I'm making video after a very long time. Okay, so we'll go shift +1, select this and this one, this selected beams, yes. Okay, so we're done here, and then we'll have the live load. So for the live load, we'll go to the command file, it will be easier for us. Live load, so we'll zoom in, so we'll copy the flow load here from the dead load part and provide it here. It will be 2 minus 2 okay, it will also be minus 3. So now you can see that load has been assigned, live load and dead load. Okay, so now comes the wind load part. So W1, let's add here wind load. This will be X, add, so this is okay. 2 minus X, and we'll give the range here. Okay, this also, okay, this also, previous one also we have to give the range. So we'll give the range here, select node beam. So we'll do the with the Y range of the 0. So minimum Y range is 0 and maximum Y range is 3. So let's give maximum 3.1, and then here the X is 8. Okay, so X will be let's say minimum 7.9 to 8.1, and Z is 4. So let's give 0 to 4.1 minus 1, add. Okay, so if you do just the sign, if you just do minus 1 plus 1, the sign will change like this. And for this one we'll add the Y range here. So you can see Y range here, this one will start from 0 to 3. This one just add the Y range, because the wind will act above the plinth level, though it is some portion below the GL also. So Y range 0 to 3 will do, modify. Okay, done. So W3 we have to add, for some reason it has skipped, add. Okay, W34 wind load Z. Okay, this is okay. W3 will be wind load Z windward face, will change later. W4 will be wind load Z leeward face. Okay, so then we'll change later. You can see Z windward face means this one is going in the positive direction is okay, but the sign is wrong. Okay, the limits are wrong. So let's go here. This is the Z windward face. Z windward face is this face. So again, this face is correct here, and W3 is correct. Only we need to change the Y range. So Y range will be 0 to 3. So this is perfect. And then we'll change W4. W4, you can see, first of all, we'll change the sign here. So let's do this direction. So it's coming this. Now we'll change, have to modify this one, 0 to 3. You can see, modify. So it's gone up, but we need to give here Z. It's 4. So Z range will be minimum 0, maximum 4.1, 3.9. okay, so now let us come to the right part here, like this. So we'll create some so we have some predefined load combination as per the IS code, but we'll go with the default auto combination this time. So it is go to analysis and design, Okay, before that we have skipped one step. I think we have here in the reference load we have to create the seismic mass here. So we'll just go take the live load here. For the live load the factor will be 0.25 because the live load is less than 3, so this will be the factor. And dead load, obviously full dead load is taken. Is there a mistake here? I think we have to delete this. Okay, dead load is defined as seismic edge, that's why it is not taking. Okay, you have to correct that. It is dead. Now we'll have the correction. Okay, now it's okay. So dead live load 0.25 factor and dead load full is taken as a seismic mass, as you know. So now we'll go to analysis and design and we'll run the analysis here. Okay, so we've not added the analysis here. So what's the warning? Let's see. It should perform analysis and change. Yeah, this is the perform analysis and change warning. So we'll go to the command file. This one we have to add perform analysis change. We have to Control plus C and then Control plus V. Control plus F5 to run the analysis. So we have now let's go design here, and you can go to concrete design and you can select the parameters and then do the design here, but we'll do this in RCDC. So let's jump ahead and go straight to RCDC here. Go select the RCDC column and wall. So we'll have the settings here. Let's go M25 here, FE 500, and select this. 500 cover 40. You can see these are the frames here, and we'll go to settings here, design settings. Okay, so let's just go ahead and basic load cases here. We'll add here. Okay, add from analysis. Okay, and this design. You can see the columns design you can understand easily. So Now let's select the any shear wall to check the design here, how is it showing here. So you can see this one, for example CW2 here. If you can see here CW2, this is the shear wall, and the design is shown here. So if you just right click, and you can see here quick section, you can see the section of the shear case shows shear wall in which it is showing. So we have to interpret here, so the along in levels here, how is it. So this is the column here, and this is another column, so 300 column and 200 shear wall. So it has given different reinforcement. So now we have to interpret the reinforcements, and then we have to this 10 T8 10 T8 10 T8 10 T8. So we have to interpret these results, and then we have to consider the design. So it does not give the most user friendly designs, but we can check whether it is passing or not, and we can have an approximate idea, and using this results we can modify this a bit. So if we have reinforcement settings, so we can change the reinforcement settings, and we can easily change the bars to know the results a little bit better. So if you just change, unlock the design reinforcement settings here in the shear wall, I think this is okay. If you use this 16 also, maximum bar for columns, it is okay. And for shear wall, minimum is minimum bar, if you go to do 10 and maximum 16. Link bar is 8 and 12, this is fine. And if you do it okay, now you can see this one. So we cannot exactly use this results here, because in shear wall we use the main bar spacing. Like suppose the main bar here, suppose if it is shear wall, so suppose if it is shear wall like this, sorry, shear wall like this. So if we have you will have two reinforcement layers. So suppose one reinforcement layer here, and then one reinforcement layer here, and then we'll have another layer of secondary bars like this, and like this secondary bars. So suppose this primary bar is 10 at the rate 200 center to center, and the secondary bar is 8 at the rate 200 center to center. So exactly we are not getting the results in this format. So we'll see how to use the results, and we'll do some research and see. Looks like we cannot use the results which are we have obtained directly in RCDC. How to interpret those results, study and make another video on that, how we can use this. But it's obvious that we can see whether the members are passing or not using the RCDC results. So till then, keep learning, and if you have any comments, suggestions, make sure to comment below. Thank you. Bye bye.